Video for the Pascal's triangle worksheet. Problem number 1 asks us to expand completely the expression a plus b to the 7th. All right, I'm going to do that using the space below. And I'm not going to do it the most intuitive way. I'm going to just add in this factor a plus b one at a time. So start with just an a plus b. I'm going to multiply it by another a plus b. This is going to give me an a squared plus ab plus ab plus b squared. And then combine like terms, I've got a squared plus 2ab plus b squared. Okay, parentheses around that. Multiply it by another a plus b. So let's keep track of how many a plus b's we've mixed in. I've got the two originals plus a third. So this maybe off to the side, I'll write this was, well, I even want to write just a single a plus b at the top as our first a plus b. Then we added in our second a plus b. Let's see what we get after adding in another a plus b. I'm going to get a cubed plus 2a squared b plus ab squared plus a squared b plus 2ab squared plus b cubed. What I'm doing is I'm distributing this a to every term first. That's where I got these first three terms. And then I am distributing the b. And that's where I got these second three terms. So b, b, b. And now we combine like terms. So this becomes a cubed plus 3a squared b plus 3ab squared plus b cubed. That's after adding in 3. All right, we've got 7 more to go. So I'm going to pause the video here, add them all in. I'm just going to keep doing it one at a time. I do realize that I could now distribute one of these into another one of itself, and then I'd have 6 of them represented, but I'm not going to do it that way, and I'll explain why in just a second. Okay, so I have the whole thing expanded here. Let's take a look at what happened. So as I folded in each a plus b, it obviously got a lot bigger. I was always able to combine like terms. And we finish with this very long expression here. This might just look like random letters and numbers right now, but there might be something kind of recognizable in it. I had to overwrite this, so I've got it copied over here. Write out the first 7 rows of Pascal's triangle. Do you notice anything when you compare it to your previous answer? Okay, so we got to get to the 7th row, which the first 7 rows, that's a little bit ambiguous. Let's write it out to the 7th row, which will actually be 8 rows because the very first row is the 0th row. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, and then our final 7th row, 1, 7, 21, look up here, look at the coefficients, 1, 7, 21, 35, 35, 21, 7, 1. The 7th row matches the coefficients of this expanded perfectly. 1, 7, 21, 35, 35, 21, 7, 1. And if we back up, we'll see that a plus b to the 6th matches the 6th row. Let's look at the coefficients of a plus b to the 6th. 1, 6, 15, 20. 1, 6, 15, 20. 15, 6, 1. And the 5th row has coefficients 1, 5, 10, 10, 5, 1. And the a plus b to the 4th, 1, 4, 6, 4, 1, 1, 3, 3, 1, 1, 2, 1, and just a plus b is coefficients 1, 1, just like the first row of Pascal's triangle, the 1, 1. And then we get the 1, 2, 1, and then this is our 0th row. So I'll post this whole thing if you want to look at it, inspect it for all those patterns a little bit more. But the main takeaway, and here I'll write this out, for your answer to that second question is that the expansion of a plus b to the x, so what we'll say is in this expanded, the coefficients in standard form match the xth row. So whatever x is, you go to that row, you get your coefficients. One more thing I'll point out is look at the exponents on a and b. They go in a very predictable order as well. A to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, no a's, and b does the reversed. No b's, b squared, b to the 3rd, b to the 4th, b to the 5th, b to the 6th, b to the 7th. So with all of that information combined, we can do a plus b to the 7th much quicker than this, which took me several minutes to write out. And it's very easy to mix up your exponents and combining like terms. I actually used Pascal's triangle to help me a lot while I created this. All right, we call that good for this video. Have a good rest of your day.